Okay, we're going to be making you guessed it, a weather map. And, just Google searching weather is pretty impressive. You get a lot of these really crazy images. But it'd be nice if we could somehow kind of quantify on the landscape how weather affects us. Unfortunately, we're not going to be able to, probably not be able to map a rainbow. But what we can do is we can use Noaa's storm events database. And this is a great database because it records all of the kind of damaging or fatality kind of causing storm events in the contiguous and maritime United States. So click this guy here, and it brings us right to this kind of this database kind of access portal here. And what we want is a CSV file because most of this data is stored in a spreadsheet, and what we're looking for are lat-long coordinates, where there's latitude in one column and longitude in another column. So I'm going to click the CSV, and I guess we're already on the CSV file one. Remember, this is comma-separated value. And it says it contains data from January 1950 to June 2015. And so I don't really want to map the year 2015 because that's the year we're currently in. And so far, the data they've curated only goes up to June. So I want to do an entire year from January through December. So let's do 2014. Let's map the weather patterns in 2014 and kind of the variation in different damaging weather that happens across the United States. So two important things. We want access to the data, but we also want some kind of documentation. So detailed information about the fields and columns, and it has two options here. It says FTP and HTTP for each one, and this means file transfer protocol, and this means hypertext transfer protocol. All that you need to know is FTP is usually a little better for like very large files, and HTTP is a little faster to do smaller files because this is how the internet kind of, when you look at a web page, it uses this, right? You used to see http://www. So the whole World Wide Web kind of uses that file transfer system. So I'm just going to choose HTTP, and let's just download the data first, and then we can get the metadata. And now we see, okay, storm events details, very good. And we see CSV, it says .gz. This is just another zipped format, so that's fine. We can extract our data from the zipped format. And it says storm events details. I'm going to just scroll down and see what's going on. Just fatalities, locations. I've already taken a look at this, and I know that locations doesn't have all of the metadata included, or sorry, it doesn't have the other data included in it. So I'm going to choose details because I want to know as much as I can about each storm event. And it goes right, here's the 2015 one that only goes to June. It goes right from 1950 right through 2015. I'm going to choose 2014 because I think that year's complete. And it says here, yep, database 2014 _ and I believe this is when it was last updated, 2015, September 17th. So I'm going to go ahead and download that 2014 file. And that's good. And now I'll go back, and I'm going to go to the HTTP version of the detailed information about fields and columns. I'll do that one. And that's a Word document, which is great. And I'll do the same with file naming convention. I'm just curious. Might as well get all the information we can. Okay, yeah, and this just tells us about how they've named their files. That's okay. I trust them. They're publicly funded, so hopefully they're doing work for us. That's good. Okay, got these two pieces of information. I'm going to kind of bring them right into my Unit 5 folder, like that. And now I'm going to extract the CSV file. There it is. I'm going to rename this Storms 2014, just so I can keep track in my own head. So I've decided to open mine with OpenOffice because that's a free program. And it asks us, okay, you want to import a text CSV, and we say yes we do. It's comma separated, right? Separated by comma. It's not tab delimited or anything else. So we say yep, comma delimited. Which row? We want it from the first row. We want to include these names kind of in what gets imported here. Okay, so I'm going to say okay. Okay, so this is cool. We get a begin day, time, year, month, just different forms kind of how to keep track of, when things happened. It tells us what state or kind of maritime area it was in, the event ID, year, month, and this is the most important, I think, is the event type. That's going to be really interesting to us because we're looking to kind of categorize. That's great. Keep moving along. Let's see. We've also got the source. That's useful. Was it, the public, somebody called it in? Was it, a station, a radio station, a weather station, law enforcement, that kind of thing. So we've got a lot of fields that I don't really care about as well. We've got location here, but this location looks like it's a town name. And that's a little more questionable. I like the looks of this right here. Begin lat, begin long. And this is telling us kind of the beginning location of a storm. And this is apparently an end location of either a storm or a system. So how can they give us an exact point? Well, clearly there are some that have, this is a track, right? It begins here and ends there. And there's some that don't have any because, for instance, this was a snowstorm apparently. And it's across a great region. So we're going to be dealing mostly with kind of discrete events, or as close to discrete as you can call it. Thunderstorms, tornadoes, things like that, floods, things that we can say this is where it happened. So I've looked at this database before, and I think that the begin lat, begin long is pretty good because sometimes there isn't an end latitude and longitude. There actually isn't an end location. And that will be our way of kind of trying to make the data set more cohesive. So we like those two fields, and we like some of the other ones. I want to simplify this so that QGIS doesn't get too confused. So I'm actually going to delete a bunch of columns. Well, let's keep the source. I think that one's good. Cool. So we should have a much simpler looking spreadsheet now that's only a few columns big. We've got episode ID, event ID, state, month, type, lat long. So I'm going to get rid of these three as well, and let's just keep it to the beginning location. In a lot of cases it looks like the beginning and end location are actually the same, but I think this will work for what we're trying to do. And delete those and delete the event narrative. Cool. The other thing I'd like to do is get rid of all of the places that quote unquote don't have a location, right? So these null values, they're places that it's an entire area that's affected, right? So we can see here drought, extreme cold, dense fog, things like that. So we're going to be kind of limiting it mostly to discrete events. Where there's one point and X and a Y, lat and a long. So to do that, I'm going to sort the whole sheet. By column F. So I've sorted the whole sheet here, and now at the bottom, here are all of my records. It appears like I have about 32,000 records that have a geographic location. So I'm going to get rid of these guys. And it's a lot to ignore, for sure. So this is something that we want to keep in mind, is that we're using only about half of the information. There's 58,000 records total. These all were kind of area events. I think if we were going to really do this kind of more in depth, we'd want to kind of quantify how many types of weather events are being not represented and are being represented, and that would be an important part to show in our analysis. So right now, though, I'm going to go with we want to make a map. Let's see what it looks like. We're going to assume that a lot of these places without a geographic point are area types of things, usually blizzards or kind of more general things. And we're really more interested in very specific, I think it's going to be mostly tornadoes, floods, and thunderstorms. So I'm going to delete all that. Okay, and now we have a table that is just latitude and longitude, and it's ready to go. It's ready to bring into Q. So let's bring it into QGIS. Okay, so if I was to just drag in my CSV file, it will come in as usual as a table, but I know that it has latitude and longitude, so I'd rather you see this as a point file where every single point is represented by a pair of coordinates. So to do that, I need to actually do something else. On the sidebar here, you'll see this kind of apostrophe looking thing, or I guess it's a comma probably. So it says add delimited text layer. So I'm going to go ahead and do that and look for my CSV file here and say OK. And then, yep, it's a CSV. It chooses that. If it was anything else, you see it wouldn't work, right? So CSV, number of header lines to discard, none. We want the header lines to represent the actual headers of each column. Point coordinates, that's exactly what we want. Now, it knows because it searches the field names and it sees lon and lat there. So it knows this is longitude and latitude and automatically kind of puts them in the right places. Why would it say X field and Y field instead of latitude and longitude? Well, that's because sometimes you're using projected data, which might have UTM coordinates or some other kind of planar coordinate system. For our purposes, we're in a geographic coordinate system where it's just latitude, longitude. Latitude is the Y field, right? The lines of longitude run up and down the Earth but measure your position on the Y-axis, and the X is the longitude. The lines of longitude run north and south but measure your position on the X-axis. So that should work. Let's hit OK. And here we go. And it says, CRS was undefined. So it defaulted, I don't know if you saw that, but it defaulted to WGS84. So our datum is something that we'll want to check before we start doing complex things. And you'll notice it actually does include Alaska here and Hawaii and Puerto Rico. But you can make out the shape of the United States just barely. I actually want to go and download some other things so that we can put this data on top of the US. Right now, we can kind of understand it, but I'd rather see where every state is and maybe some topography. So the next video we'll go download an elevation model and a state shapefile.